I hope everyone is doing good this morning. I am Mr. Ish. Thank you for joining me. In this question, we'll be looking at a variety of things in terms of the properties and the angles and all of that you've learned so far, all of that coming into play. We have a representation here with this circle and these inscribed triangles. This segment C and D represents the diameter. This point here, 0, represents the circle center. We have a specific point here, P, from which these lines are extending to. Remember, at any point on a circle circumference, if you're connecting it by ends of a diameter, you're always forming a 90-degree angle. So therefore, point P represents a 90-degree angle. A, B, and C will cumulatively add up to 90 degrees. We have to find Y, Z, A, B, and C. X we know is 25, so let's put that in here, 25. It's not a very hard question if you remember the fact that from 0 to C, from O to C you have a radius, then from O to P you also have a radius, so these two sides are equal. Then they must be opposed by equal angles. This angle is opposing that side, that angle is opposing that side. They're equal sides, equal angles, therefore A over here must be 25 degrees, which generates this isosceles triangle. So this right here is 25 and we can bring it into play. What else? Now if you look right here at this B, C, and 25, they cumulatively add up to 90, so we know B plus C must be 65, because 65 plus that 25 will give you that 90. However, now let's come over here at this large triangle. You have this segment O and D, which represents a radius, then we have O and P, which represents a radius. The angles which oppose it must be equal to each other. Z is opposing that side, B and C are opposing this side. B and C, 65, are opposing this. Cumulatively, 65 degrees is opposing that. Therefore, Z must be what? Well, if B and C represents 65, then Z must also be 65, because both B and C in their sum, in their cumulative measure, oppose a radius. Z opposes a radius and they're both equal. The angles must therefore be equal too. So Z over here must be equal to B plus C, which is 65. But we know this right here is 65, that's 65, so we can bring in these measures right over here, and then we can do the sum of the internal angles of a triangle equaling 180 and find C. C is going to be equal to 180 minus the sum of 65 and 65, which is 130. So you'll do 180 minus 130 and you know you're going to get 50 degrees. So that tells you C is equal to 50 degrees. If you've determined C is equal to 50 degrees, you can easily determine B from right here. It's 65 minus 50, which is 15 degrees. So now we have everything coming into play. So how do you find Y? It's not going to be too hard, because you can easily find this extra obtuse angle right here. This right here is 15, this right here is 50, this right here is a test. 25 plus 15 plus 50 should give you that 90, and it sure will. 25 plus 15 plus 50 gives you that 90 degrees, so that checks out. Now to find the angle, measure Y. If I know this is 65, then this right here, by means of supplementary angle properties, the 65 plus that missing angle must equal 180. It'll be just 180 minus 65, and that's 115. This right here is 115 degrees. Now for this obtuse triangle right here, we have three angles. We have a Y, 115, and a 15. You can easily determine Y. Y will be equal to 180 minus 15 minus 115, and that will give you your answer that you need. It'll be 180 minus 15 minus 115. It'll be 50 degrees. So let's put what we have. We've gone A is 25 degrees, we have Z is 65 degrees, we have X equals 25 already provided, we have C is equal to 50, we have B is equal to 15, and then we have Y is equal to 50. What are our ways of checking this out to make sure everything is right? Well, we do have ways. If I look at this large triangle CDP, there are three measures, 25, 65, and 90. They should add up to 180. 25 plus 65 plus 90, it gives me 180. So that checks out. Now let's look at this small triangle right here. You can do 65 plus 65 plus 50, and it adds up to 180. You can do this small triangle here. You can do 50 plus 115 plus 15, it adds up to 180. And lastly, the sum of these three angles here should always equal to 90 degrees, because when you connect the ends of a diameter to any point on the circle circumference, you generate 90 degrees. 25 plus 15 plus 50, and you have 90 degrees. So everything has been solved. And we did this question entirely using the property of circles, properties of isosceles triangles and angles, and the radii which generated those angles. And that's it for this particular video. The question is complete and everything is presented for you. Thank you for watching. Have a good day. Bye.